elliptic equation typically associated with the steady state behavior. For example, here we write Poisson equation del squared u over del x squared plus del squared u over del y squared equal to x exponent y. Alright, exponent power y. So in this case, we can see that we have two-dimensional problem. U is a steady state, for example, the wave equation. Okay, x and y is a space to represent the location, the solution domain of the u, x, y, or u, x, I, y, j, or we can write in the simple discretization u, I, j. So now let's go for the example, Poisson equation, which is not equal to 0, right? Del squared u over the x squared plus del squared u over del y squared equal to x exponent y. Alright, so now we consider the problem is in the boundary between x equals 0 and 2 and y between 0 and 1, and then the size of interval of delta x or equal to h equal to 0.5 and delta y equal to k equal to 0.52. With the boundary condition, okay, we have four boundary conditions. The first is y between 0 and 1. Y is between 0 and 1. When x equal to 0, u is equal to 0. When x equal to 2, u equal to 2 exponent y. Right? And the second is when x equals 0 to 2. If y equal to 0, u is equal to x. When y equal to 1, u equal to x times exponent. So let's go to find where is the domain of the solution between x 0 and 2 and y between 0 and 1 with the size of interval 0.5. Right. So now, okay, as usual, we want to solve the parabolic equation of elliptic. Alright, is au equal to b. Okay, we want to solve, we want to generate a linear system of equation, and we want to solve using iterative method called Gauss-Seidel method. To solve Gauss-Seidel method, we need to have an initial condition where u always 0 for every I. Alright, so now we can solve this problem using 5 steps. The first step, we need to determine the domain of the solution. Where is the domain? Alright, so we have four boundary conditions here, and the size of interval is 0.5. So the number of grid for x-axis is 4. Alright, b minus a divided delta x is to find the grid for x-axis. And b minus a divided by delta y, we can find there are two grids at y-axis. Let's draw the graph. Alright, so x is between x0, x1, x2, x3, x4. We have four grids here where the size of interval 0.5. So x1 is 0.5, x2 1, x3 1.5, and x4 is equal to 2. Y, we start with y0, y1, y2. Alright, so our function now is to find the solution of the parabolic for the Poisson equation of elliptic type. Okay, the solution is in the center, in the middle of the boundary condition. There is four boundary condition: boundary condition 1, boundary condition 2, boundary condition 3, and boundary condition 4. Right? So we have four boundary conditions. Alright, 1, 2, 3, and 4. Alright, so this is the location of the boundary. We need to use this solution of boundary when we generate the grid u11, u21, and u31. So this is our function to find what is the wave when x equal to 0, y equal to 0.5. Okay, u2 is when x equal to 1, y equal to 0.5, and u31 when x equal to 1.5, y equal to 0.5. We want to use the value at the boundary and initial condition. now we have generate 4 boundary conditions. The first is when x equal to 0, y equal to 0, 1, 2, alright, is equal to 0. When x equal to, okay, 2, okay, or x4, alright, I is 4, so the equation u equal to u 2 times exponent yj. And then the boundary condition number 3, when y is equal to 0, okay, u will be xi. And boundary condition number 4 is when y equal to 1, or when j is equal to 2, so u is equal to si exponent. So this is a boundary condition that you need to fulfill. Now let's go for the first step, how to discretize elliptic equations.